Okay, so we started a little bit of coding to create that bar chart thingy. We're gonna go back to it and we'll continue it. But before doing that, um, I want to talk about some basic concepts of C language. Understand the specific terminology with respect to operators. So operators, we need to know what they are and how they work. So we're kind of going to analyze it and look at it closely and see what we can do with it. Just if you ever are in a position to develop any system, I have to give you a feedback that is pissing me off on the applications that I see out down there. You know what hover is?
Hover,
Yeah, you bring the mouse over something and it changes its shape. Please don't do it. Awful. Like, take a look at this. I have my stuff ready so I can go through it one by one and explain it to you. Now I want to come and click and bring this one on focus, right? So I'll bring my mouse and suddenly close appears. So I think I'm activating it, but as soon as I click it, I close it. Stupidest thing anybody can do. If you wanted the damn thing over there, just let it be at the side. Don't make it hover suddenly out of us. And this, like, and it appears not only here, and like that's Notepad. You see it in websites and stuff like that. It's like the most horrible thing to do. So if you are ever in charge, it's awful. Users are suffering, don't, especially somebody who has to do 50,000 things over and over. And I just bring the mouse and I click and, anyways. So I'm going to create a file over here, a resource file. Add a new item, and it's going to be utility, and it's going to be a text file, and I'm going to call it operators and operands. So to kind of analyze to see what operators are and how they look like and all the good stuff, I am putting some placeholders over there. So when I say A type, it means a type. B type is a type, C type is a type, and A is of an instance of A, B is an instance of B, and C is an instance of C. Okay? So it could be integer A, double B, employee C, anything. You good with this?
Yeah.
Down to this point? All right. Now I want to go through certain terminology and see what any specific thing means. So we have so many different operators, and the only thing that, like one of the things that is not used as an operator is @ sign. So I'm going to use that one over there to use a general operator placeholder. So when I say A @ sign B, that could be A plus B, A minus B, A multiplied by B, A divided by B. Okay? Any okay? So we call that thing an operator. A and B are called operands. Okay? So essentially, I have a function and I have its arguments. What is an argument of a function? You feed a function with arguments. It does some process on the arguments and creates a result, right? With an operator, you give its operand. So unlike a function that you can have 10 arguments, operators are very limited. There are specific rules, math rules that you have to follow to identify what is which one. So So essentially what I mean is that I have A plus B, A minus B. So A is left operand, B is right operand, plus is an operator, and plus's job is to get the A operand and the B operand, do some process on it, and return a value, whatever it is. In this case, it's the sum of the two, and the other one is this, A will be reduced by B. Are we okay? Okay, so binary operations, like the very first category of operators are binary operators with no side effect, which is essentially what you see right now. Okay, now I'm going to put an assignment at left. I'm not talking about assignment operator. I'm talking about anything but an assignment operator. So these are all operators that they don't have side effect. And what do I mean by that? It means when I say A, so I'm not talking about these operators. My focus are these, right? So these operators, they don't have any side effect. Or I can do this. Sorry, that semicolon is like a muscle memory that comes in. Okay? So when B and C addition is happening over them, B and C will not change. It remain the same. They remain the same. C and same thing over here. So all these things, the operands will not change. They call this binary operators. Why? Binary means two. It means left and right. It means they have two operands. Okay? Binary operators. Are we okay with this? I'm just setting categories so when we talk about different things, you understand what I'm talking about when we go to it.
So
that's category number one. Yes?
does B have greater than C a value to 0 or 1?
We don't care. I'm just talking about focus. I'm just talking about what the type of the operators are. Okay? This is a binary operator, means left and right. We don't care what they do. We just, okay. All right. So things like that. So this is good.
Yeah, it does. At 0 once, I think. Let's change detail. It does some stuff.
So essentially, this will be the definition of a binary operator with no side effects. So essentially, A will be set to B at C. B and C remain the same afterwards. Are we okay with this? Okay. Now, we have binary operators with side effect. Binary operator with side effect is A will be set to whatever, but B will be set to, again, this is wrong. I cannot mention it like this. What I should mention over here, A will be set to B and C, and B or and B and or C may change after the operation. Okay? Which essentially means something like we okay? With regular operators, I don't have any operator that changes the right operand. There is no example for it. But the meaning is this. Are we okay down to this point? Okay, so these are binary operators. Then we have unary operators. Unary operators, they have one operand. And almost all of them are prefix. It means they come before, which is essentially something like so I'm going to say over here unary operators with no side effect. So essentially I can say A is set to minus B, okay? Or at sign B, anything that it could be. Example for it will be A set to minus B, or A is set to plus C. Okay? That operator will receive that single value as an operand, does something with it, and the value is returned out. Are we good? Unary operators with no side effect. What are unary operators with side effect? We only have 4 of them. In reality, we have 4 of them. Okay? But again, these are the standards that come with C language. So unary operator, we have 2 unary operator. So these are, sorry, I should say prefix. That's important. Unary operator with no side effect. Then I have prefix unary operators with side effect. Okay? Which is essentially, we have only 2 of them, right? A is set to at sign B. So the example is A is equal to plus plus B, or A is set to minus minus C. Are we okay with this? And the final thing that we have is postfix operators. Postfix operators with side effect, and it's not only that we have only 2 of them. Postfix unary operators are only 2. We don't have like many prefix and only 2 of them are with side effect. We only have 2 and they're both having side effect. Okay? So prefix unary operators with no side effect, prefix unary operators with side effect, right? And we have postfix with no side effect. And there are no examples for it. We don't have such a thing. Standard coming with C++. There is no such thing. All right? Are we okay with this? So this is essentially all the ballpark of what operators are and their categories are. Okay? Any problems?
Was there an example with binary no side effect?
Didn't I put it?
You can't see it.
Binary with no side effect?
Yeah.
That was the very first one.
I know, but I missed.
It's essentially any
Yeah. The normal ones, yeah.
any operator that you've done in math falls to that category. And one of the most famous binary operators with side effect is this. the assignment operator itself. It receives the left one, sets the other one, and returns the value, right? So all operators, again, all operators are the same. They return a value. Yeah. Are we okay? Are we good? Are we okay? Yeah?
What does A equals B equals C do?
Pardon me?
What does A equals B equals C do?
It first sets the B to C and then A to B.
Oh, okay, so it's right to left. Yes.
Okay. Questions now to this point? Suggestions? Objections?
It never left right.
All right.
I see.
So
Something about that. Hmm.
let's create a class. Like many of you have used the string class of C++, right? You were not supposed to. So don't use it. You're not supposed to. It's only 3, 4, 5. So if you use it, make sure you don't anymore. Okay? You're only supposed to use C. C strings, not C++. But let's say we want to write the class ourselves. Let's say I want to create a string class, so I'm going to create, so in here I'm going to say include. Okay? Let me bring the C string class, the C string that we have for our, I'm going to bring add existing item. It should be in your workshop, right? So 244 workshops. Which one was it? Workshop 0 or 1? One or 2?
Both.
Both? So probably 2 is, if there is a lab. So these are the 2, right? Copy. So these are essentially the C stuff that we do, right? It's C functions. I don't want to use them. I want to have a string. I want to have a string that acts like a variable. So let's include, and then later I'm going to change this thing to a, module. But
Why are they called strings?
you were saying?
Why is it called a string? Those custom functions, why are they called strings?
You don't know what a string is
Oh, you
in
mean
English?
string. I thought you meant, sorry.
Yeah.
Literally,
Okay,
it's
okay.
confused by an old language.
Okay. So cstr dot h.
Basic.
So I'm going to create namespace Seneca. I'm going to put it in namespace Seneca later. I want our focus to be on this. So I'm going to create a class called string. Okay. So what essentially is a string? A string is a null terminated array of characters, right? A null terminated. For now, I'm not going to make it dynamic. I'm going to make it regular because our focus is on operators. So I'm going to make it an easy one. So, and later on, we can convert it to dynamic later on. So in here, I'm going to say character data, and let's put 4,096 characters in it, big one. Okay, so for now, we're going to deal with this. And I'm going to create a constructor for this, and I'm going to say string, and the string, the default string that I have, will set mdata 0 to 0. Right? Essentially makes it an empty string. So to make it easy and good and nice, right? We okay down to this point? Okay, so I want to be able to display a string. Okay? I want to be able to show a string. So what I will do, I'm going to create, and let's create another one, another constructor, string, which I receive a constant character pointer data. And in here, I'm going to, so in here, let me actually write this thing in a Seneca namespace, Seneca, so I can use the CSTR easily. So in here, I'm going to say str copy into mdata, the data, right? So essentially, whatever I have, it's going to copy into it. Are we okay? We can make it smart too to make sure it's not going to make any boo-boo. So I'm going to say if data exists, do this. Okay? If it doesn't, then mdata 0 becomes 0 without an empty string. So if somebody doesn't give me any data, this is null, it's not going to crash. Okay, so it becomes a foolproof thing. Are we okay with this? Yeah, and I want to be able to, display this. So to display this thing, this is the rule that I want you to follow from now on. Blindly, and then I'm going to tell you why. Okay, so the signature of a display function must be as follows. The signature of a display function must be as follows. It should be OStream reference display. I'm not using namespace. Let me just use using namespace std, and receive an OStream, name it something else, OSTR, and by default, set it to cout. Cout is an object, right? Yeah. So I can just say, so by doing something like this, I can display whatever I want. Using OStream, it's as if I am displaying it using cout. But if I don't want it to be cout, I want it to be some other type of output, because cout is a child of OStream, and OStream has many shapes. We are now using the console output, but after the midterm, I want to use files. Files are OStream too. They are all children of the same thing, so I'm just going to do that. For now, blindly use this, and use OSTR to do your printouts. Yes?
Quick question. In the condition for the if statement, don't we have to check if the element at 0 is a null?
Okay, good question. Why didn't I check to see if, so you would say if data, so what you're saying is saying if data and data, right? Is this what you're saying?
Yeah, it is not null.
It's thumb and null pointer.
Yeah, basically that. Yeah.
So a string is an array of characters. Thank you for the question. It's a good question. So essentially, because it's a string that it's an array of characters, it looks like something like this. Correct? So this is the data, and this is where the data is. This is the data pointer, and this is where the data is, right? Correct? Now there are two possibilities for this. Either the very first one over here. Control.
What is OStream data exactly?
The first data over here, either that could be null, which means the pointer is pointing to a piece of memory, but there is nothing in there. It's like you have a plate, but it's empty, right? Second possibility could be that you have the data, but that data itself is pointing to nothing. This is data being null. This is array being null. This checks for this not to happen. This checks for that not to happen. Does that make sense?
Yeah.
The thing is, string copy is already checking for that. String copy can simply copy a simple thing, right?
Yeah.
Although this doesn't make any difference, it will work, but not writing it will not cause any trouble either, because string copy copies this perfectly. It copies an empty string to another one, makes the other one empty.
Yeah, as well.
So the second one is not needed to be checked. Yes.
I don't understand what OString is doing.
Who is doing?
OString.
OStream.
Yeah.
I'm not doing anything here yet. Let me finish it, you'll see. I'm just talking about this one for now. We'll come to OStream. Are we okay?
Let's say, for example, we don't know the size of a parrot, so we have to check for length of parrot first.
No, you don't need to. Because the reason that I chose 4,000 characters, it's just to ignore that for now. If it was dynamic, then we would do all those things. By the way, we're just thinking hopefully it's not more than 4,000. I want to focus on operators, so this is a crappy code, okay? This is a crappy code, but I'm hoping that the data that is coming in is not more than 4,000. If it's more than 4,000, my program's gonna crash. Hoping that it's not more than 4,000, I'm writing the code. Later, I'm gonna convert this to a dynamic one, then sky's the limit. You can put anything you want in it. Does that make sense? All right. So now that we have done this, let's talk about the OStream thingy that we have over here. This is the first time that I'm introducing this signature for you. And the reason I'm telling you this, I'm saying you will not understand why I'm doing this. You will know in future. For now, trust me, this is supposed to be the signature. But what I'm going to do here is this. I'm going to say over here, so if I wanted to print this with cout, how do I print it? I go cout mdata, right?
No,
It's to print it out, correct?
it's a custom function.
Correct? It is mdata, correct?
Yes.
And I'm printing it on cout. But OSTR is a new name for whatever is coming in, right? So instead of cout, the rule is to use OSTR. And then at the end, return OSTR. Why? Because the sky is high. So from now on, write it like this. Give cout a new name. Use that one instead in this function instead. Doesn't make any difference. I'll show it to you. You'll see it's going to work. So now, in my main, I'm just going to test it right now. So in my main, so are you going to be very mad if I put this thing in a module, separate module, this string? I want to put it in a separate module so it makes more sense. Like this,
Isn't it supposed to be part of one object though?
what? Being,
The output, isn't the string supposed to output itself or something?
oh, that's, I don't know what does it mean. I don't know what that means. That,
I see what you're doing.
okay. So I just want to take this thing and make it a separate module. How I do it, doing the same thing. So I just want you, by doing, let me just write the main for you first. So in here I'm going to say, because I'm outside of the namespace Seneca, I'm going to say using namespace Seneca, and I'm going to write my main here, int main, to test this. But soon I'm going to change this. So in here I'm going to say string, name, and in here I'm going to say fardat. Right? And now I'm going to say name.display. As easy as that. Okay?
So OStream is.
And then I'm going to say cout, whatever.
Sorry, it's a little bit distracting when Julia
That's okay. That's okay. She's gonna raise her hand. Don't worry. Yeah.
I'm having
That's okay. No, no. So what happens over here is this. The name far that's going to be here, the name display, and then whatever comes next. So now the name is going to, the name gets initialized. So we're gonna start like this. So the name is getting created. It goes to the structure. The data over here is far.dat. Far.dat is not null. It copies far.dat in mdata. Mdata becomes far.dat. Now my string holds far.dat in it. Are we okay with this? Then, now I'm saying name.display. I didn't put anything in name. Therefore, the default value will be passed to OSTR. Therefore, OSTR becomes cout. Are we okay with this? Now we'll go up to display. Display is going to print mdata, that is far.dat, which is going to be this. Correct? Right?
Yeah.
Then it comes out. It returns OSTR that gets evaporated into cyberspace because nobody grabbed it. So name spit out the O stream, right? But nobody captured it. So it's gone to waste. Now the next line, I'm saying whatever. So what happens, whatever is going to get printed right after that, right? Which is very ugly. Are we good down to this point? So now take a look at this. I'm going to stop this. Now, what is display returning?
The string.
What is display returning? Look at the return statement. What is the display returning?
OSTR.
What is the type of OSTR?
It's a car, I think. Oh, it's an O stream.
It's an O stream reference. Are we okay with this? OSTR is an O stream that is cout, correct? So your display is returning cout. Correct? Remember about crazy reference that you told me? Explain. This is called crazy reference. The display is returning a reference, correct? So the function itself becomes a new name for whatever it's returning. Now, I can do this magical thing over here. Windows 11, why you are doing this to me? What the hell is this? How did it happen?
Is those
To grab the window.
All right, so now I can come to this display and I can, name is returning cout, right? I can just do got it? So by doing that, I am inserting NL to whatever display is returning, which happens to be OSTR. Therefore, I'm going to have it printed on new line. So when I run this beautiful program of mine, now it's going to be far.dat and whatever in the next line. We good down to this point?
Yes.
Okay. This is called cascading effect. Don't waste the return statements of your functions, of your methods. Use them, because you can always grab them and do something about it. I'll explain later on what else you can do with it. So we are good down to this point, right? So now I created the string and I can display it. Right? Now let's actually modularize it, if that's the word. So I'm going to right click over here. I'm going to say add a class. And I'm going to call that, it's not going to create it. You know why it's not going to create it? Because I already have a class called string in here. It's going to say, hey, you have a string. Why you are not allowed to add a class with the same name? So what I'm going to do, what should we call this? Let me just rename that thing. Or I'm going to remove PRG from project. So let's remove this. I'm not going to delete it. Now I can add the class. I'm going to say add class. Now I'm going to say string. Okay, and it's going to add the header file and the module. So I'm going to come to the header file as usual. I'm going to say over here, if not define This is the common mistake with everyone. I told you never copy the safeguards from another header file. Remember that. Many of you made this mistake and your program didn't work. So you have to make it out of this one. So this is going to be string H and C and V. Now define namespace Seneca okay. All right. Now we have done this. I'm going to come in the CPP file and I'm going to say namespace Seneca, and now we can split our string from main into proper things. So I'm going to bring back the screen, add existing item. I'm going to bring back my main, prg.cpp, and I'm going to bring the prg. I'm going to take this the string from here. Actually, I can bring it with the whole namespace. Like this. X, remove it from here. Come to the string in here. I'm going to just paste it over here, Control V, and then come over here, print it, paste it over here too. Now I'm going to remove all the stuff that I don't need. So this one is supposed to only be the header file. Therefore, all the bodies are gone. Bodies are gone, and bodies are gone. I am in a header file. Attention, attention, Achtung, listen to me. This is extremely important. OStream is not defined. Can I include IOStream and say using namespace std? The answer is no. You can include IOStream. Obviously, you have to. So in here, I'm going to say include IOStream. But you are not allowed to say using namespace std. Header files, you're not allowed to do them. You have to individually qualify this std and std. Remember, never use using in a header file. Are we okay? Yes, sir.
So we can use it, but we don't.
No. Yeah, it's not going to give you a syntax error. Is it? Can I shoot myself in the foot? Of course you can, but don't. It's going to hurt. It's the same thing over here.
Why don't we use using?
Because it becomes hidden logic. That's a good question. Why we should not use using? It becomes hidden logic. Anybody, including your string, is going to start using std without knowing it. You follow what I'm saying? Suddenly opens its program to hundreds of different objects when it's not needing it. So using in a header file is hidden logic. You're not supposed to do it. Okay? So that's done over here. Now we're going to go to string over here and fix this. So here I'm going to remove the classes and only leave the methods and a constructor. Organize it. Bring them at place. Then copy and paste and put scope resolution over here so we know it belongs to a string. I'll copy and paste and paste. This is the lazy way of doing it. Now, in here I'm going to say always comes before, so include IOStream. It always comes before custom one, and now I can say using namespace std because I'm in my own file and it's not being included anywhere. Are we okay with this? So I just fixed my, are we okay?
Why do you remove the other stuff from the CPP?
Why did I remove those from CPP?
Yeah.
I'll show you. Because I have them in a header file. In header file, I'm explaining my class string has data, has a constructor, has one argument constructor, and a display. In my CPP, I am defining. This is called declaration. This is called definition. Now I'm saying the string that is defaulted, the string that has no argument is implemented like this. The string that has one argument has implementation like this. The display that has, so everything comes over here. And I made a huge, humongously big mistake.
The constructor?
No, I don't need a constructor. No, because the class doesn't have any dynamic memory. The huge mistake I made, ladies and gentlemen, is that I have default value in my definition. Default value only exists in declaration, not in definition. Default value only in declaration, only in your header file, in your function prototype. You never put these default values in the declaration. Compiler is going to give you an error. Are we clean and nice to start doing some? Yes, we're good? All right. So now that I have created this beautiful string of mine, let's add some action to it. So now I can get, let's actually do a read. Why don't we do a read? Let's do a read so I can put stuff in it. So read is exactly the same way. So I'm going to say std istream, because I'm reading, read std istream reference istr, that is actually std cin. So it's exactly the same way, right? And another huge mistake that I made over here, it's one of those but it works scenarios, okay? That is, you have to look at your logic. Is display supposed to change the string? No. So you have to enforce it. It works, but enforce it. How do we enforce it? We put a const here. And we add that one over there. The people at the end of the class, I'm short in real estate over here. Tell me when you can't see anymore. Is this good? Can you see? Okay, so better? Okay? Okay, back there? Okay, all right. Sorry, it was too big. I couldn't actually do anything. So now in here, I'm going to add the const. And I am kind of okay now. Now let's do the read. I'm lazy. I'm just going to put the thing over here, go to the screwdriver, and say create definition in a string. Poof, it creates an empty thing over there for me. So I can actually start doing it, okay? And it adds the std too. Let it do it, doesn't matter. Okay, so how do I read in here? Remember about getLine? I said cin has a getLine thingy that accepts the spaces too. Okay, so I'll do that. I'm going to say over here istr dot, because it's the same thing as cin, right? I'm going to say getLine into mdata 4096 character max. And then return istr. Exactly like this. See, it's like exactly the same thing. When you do one, just repeat your style and everything's going to go forward. Are we good?
You're going to post this, right?
If I sneeze, if I go, choo, it's posted. So literally at 43 minutes and 10 seconds, you're going to hear, you heard a sneeze. That was me. Everything is posted. Okay. So are we good down to this point? Now let's go to our prg.cpp and see if our module actually works, is set properly or not. In here, I'm going to say include. Do I need to? Okay, let me just do this. Include string.h. My question is, do I need to include cstring.h? No. No. Do you see any functions being used over here? No. It's extremely important. Just in case includes are extreme turnoff for me. You only include where needed. Only. And never just in case include. Never include a header file in another header file because the CPP file is using it. Never. Only use include in your header file if your header file has something that needs an include. So includes needs to be done only where they are needed. Are we good? Okay, so now the next thing we're going to do over here. So if I run it now, oh, I forgot to remove that include thingy. Oh, build errors, nice. Let's see what it would do. str copy maybe unsafe. I'm not doing str copy. Where? Oh. Here I need C string, not there. So in here I'm going to say include.
No, it's CTR string.
Include cstr.h, that is better. Now in here, I'm going to remove and compile and run one more time. Control F5, 3 years later, 4 years later, 5 years later, and here's the result. Fardad, whatever came up, so we're good. Are we okay? All right, so let's make this thing a little more exciting. And I can actually read stuff with it too. So in my main, I can do things like, instead of doing that, I'm going to create an empty name. And here I'm going to say, cout, what is your name? And I'll go over here, new line, and I'll do that. And now I'm going to say name.read, right? And then I'm going to say cout, hello, display cout welcome to OOP244. And let's get rid of that whatever thingy. Return. Are we okay? So now if I run this program, it's going to ask me for the name, and then you'll see what is your name. Fardad Mandu. Hello, Fardad Mandu. Welcome to OOP244. Are we okay with this? All right, good. Now, next. What if I have Fardad and I want to add Salimanlu to it? So I want to be able to add a string to another, a C string to this. So I'm going to say over here, add. And in this add thingy of mine, I'm going to say constant character C string, right? I'll do this. So now in this add of mine, it's not a constant anymore. It's not a constant because I have to change the values. Now in here, I can say simply strcat to mdata the CSTR, right? I can do this. There's no problem with this, right? Are we okay? All right. So I can actually go to main and do the exact same thing over here and say, what is your name? Fardad. What is your name? Fardad. What can I add to it? I'm not going to go with what is your name. Let's make it simple. I don't want to be realistic. I just want it to be. So in here, I'm going to say STR now. Okay. And in STR, I'm going to put some value. So I'm going to say over here. Oh, by the way, assignment at the moment of creation is the same thing as one argument constructor. It doesn't make any difference. So I can write over here like this. ABC. This is the exact same thing as ABC. Exact same thing as ABC. These three lines are identical, ladies and gentlemen. And don't tell me why. Because they are.
That's not intentional, right?
No, that's not intentional. Okay, so I'm going to just comment these. Now I can say str.add def, and I can say str.display and go to new line. Are we okay with this? Yeah. Right? And I can run this. And I'm going to have ABCDEF. Are we okay with this? So we are going somewhere. Now, what if I have What if I have something like this? So now I'm going to call it S1. And I'm going to have over here S2. And I want to have S1 dot add S2. What if I want to do that? So the idea is the exact same thing as the other one. So in here, all I need to do is this. Instead of C string, I'm going to say receive another string, SS, that is constant. And I'll make sure it's a reference so I don't pass too much information back and forth. Now that I have that one, I can actually go over here and add the definition. And I literally can say, you can reuse code if you want to. I can say over here, add s.mdata. The good thing is that if you change any logic in your add, then everything's going to take effect. So it's the same thing, right? It's just simply adds the data of the other one to this. So essentially, now my thing is going to work like this, right? So now I can say s1.display s1.display and L. Are we okay with this? Are we okay? Right? I want your absolute attention, all those sleepy heads. This is an important moment. Okay? What does this add look like? Take a look. In here I'm saying S1 add S2, right? Doesn't it look like this? That's essentially what it's doing, right? So S1 add S2 is as if you're doing plus equal S2 to S1. It's the same thing. You're adding the value of that one to this one, right? See what I'm about to do. I'm simply double-clicking on add and write operator plus equal. You see that?
So the operator.
Let's actually create new ones so you can see what I'm doing. I just copied, and in here I'm saying operator plus equal, operator plus equal, right? And I'm going to come in here and just copy these. I'm just showing you that I'm not doing anything special. I'm just renaming the functions. You're with me? I just renamed the functions. It's exact same thing, nothing is changed, right? So now,
Take a picture of that stuff too.
Is it B?
thank you, thank you, thank you. Get out of here. Okay, so let's go back here. Now take a look. See what I'm going to do? Didn't I name this plus equal? Operator plus equal. So in here, instead of add, I'm going to say operator. You see, it's actually showing it to me. Right? Right? And in here, I'm going to even say this. S1 dot operator plus equal EFGHI. A, B, C, D, E, F, G, H, I, right? correct? And I run it.
It's not going to display because you have.
Pardon me?
Is it going to display because you're not displaying S2?
No, it's going to display every. Oh, did I add it to S? Oh, I did S2. I'm a bad person. Thank you, thank you. It's S1. Why did I do S2? I have no idea. It's all S1. Control F5. One more time. Yeah, thank you. Much appreciated. Come on, come on, come on. Okay. So it's going to show everything. Are we okay?
Can I take a look at stream.cpp?
Are we okay? All right.
Can I take a look at stream.cpp too?
Do whatever you want to do.
Um,
Okay, so are we okay down to this point? Now, the good thing about operator plus equals is that this is actually an overload for plus equal operator. The one that we have, it gives it a new meaning. You can call it in two different ways. The function form, as you saw, it ran. Or you can just use its operator space. Potatoes, potatoes. They mean exactly the same. Are we okay with this?
yeah.
So now you run it.
Stream.cpp.
Now you run it. Now you run it step by step. This is what's going to happen. So it comes over here, creates them both. Now it comes to plus equal. Plus equal only knows primitive types, 8, 10, 20 something. So it doesn't know what it is. Therefore, it gets the left value, that is S1, okay, and right value. Do I have a plus equal with a string left and a string right? The answer is yes, it's overloaded. So it goes to that overload and does exactly what the add is supposed to do. And the same thing for the constant. And as a result, you're going to have that. This, ladies and gentlemen, is called operator overloading. And again, remember, it is overloading, which means it is overloading, which means it has no relation with the behavior of plus equal. If I was nuts enough, I could make that thing reduce the string if I wanted to. I can do anything of what's just a function. You don't have to do addition in plus equal. If I'm crazy enough, I can make that thing print stuff instead. It's an overload. So don't expect anything that the original operator did will do in here. You are redefining it from scratch. Do we understand this? And that's operator overloading. And one more thing. If you don't have a paper that allows you to have a cell phone, okay, put the cell phone away out of your desk everywhere. Remember I told you if I see one person laughing at their cell phone or looking at their cell phone, I'll take everyone's away. All the cell phones off the screen, off the thing, I don't want to see any of them. Okay? Cell phone off, please. I know, you didn't do it, but hey. See, I like to drive 200 kilometers an hour. Why am I not doing that? Because somebody did and killed a family. So now I have to go 60, like everybody else. That's the rule, okay? All right.
Can I just take last pieces?
All right, so that's that.
Stream.cpp.
Oh, that's that. And let's go back to double screen again.
Can I just get a picture of stream.cpp?
I am bringing it up.
Thank you, thank you. I just lost one with all the code in the issue. I'm sorry about all this. Yeah. One with the actual.
Okay, so now as you see, this one is having a side effect, right? It doesn't, and one thing I have to mention, Um, uh, where is it? The main thing. I want to see what is a good example for it before I do anything. So let's do something else. I'm going to do something else now. I want to say I want to be able to do this. That's how it's supposed to happen, right? I want to be able to, or put it in here, it doesn't matter. Or, and then over here say s.display. And same thing over here. I want to be able to do this and go s.display, right? Right? In reality, what happens when plus equal does the thing that it's supposed to do, and it takes the S2 and adds it to the S1, then S is supposed to be set to S1, correct? That's what it is. But what is S returning?
Void.
That sucks. It is supposed to return S1. Who the plus equal belongs to in here? Who the plus equal belongs to here? S1, correct? S1 is the owner of plus equal. So if I could somehow refer to the owner of S1 in here, I could have returned it, right? Now, if I told you, if somebody's like let's say my friend is over here, is extremely sleepy, he came in class like 15 minutes before this, almost deep sleep, and I'm teaching, okay? And suddenly halfway through the class, he wakes up and looks at the person beside him and says, where did they teach to OOP244? What you gonna answer?
Today?
No, where they are teaching.
What teaching?
You gotta say,
Which class is this? B.
no. Anybody can see, exactly, do you see the number of the class?
Yeah.
No, so if you wanna tell him so he's satisfied, you gotta say which class?
This class.
This class, correct? That explains everything, right? This class. So that we have in C++. If you are in the operator, you can always say this class, okay? But the thing is that this is the address of the current class. If you want real this class, you have to dereference it with that asterisk. So what I can do, I can fix all these, and as a matter of fact, this is something that I always tell to my students. When you are creating a method inside a class, and that method of yours is returning void, don't do that, don't waste it. Always make that one to return the owner. It's gonna add cascading to it for future. So now, this void thingy that I have in here, I'm just gonna change it to a string reference. So all these voids, I'll change them to string reference. And now inside this, I can say return this, which means in here, let me add all this. I'll return this over here. So So in here, S1 plus equal is called, correct? S1 plus equal comes over here and does a plus equal. Gets the other string, adds the data it has, returned me. Who is me? S1. So S will be set to S1. In line 14, S2 is adding S1. It comes to the operator. It adds the other one that is S1. Me here is S2. When it says return this, S2 is returning to us. And therefore, we're going to have cascading effect. Yes, go ahead.
Where is this defined?
It's part of, where is for designed? Where is while defined?
Oh,
Where is do defined? It's part of the language.
Oh, this is.
This is a keyword. That's actually a good question. This is actually a keyword of C++ language. It doesn't need any type of header file. It means the address of the current object. Therefore, it doesn't mean anything here. If I write this over here, say, what the heck you're talking about? You're not in an object. There is no object here to be this. So you cannot be in a standalone function and say this. The only place you can use this is a method that belongs to a class. Does that make sense? All right. Next time, come with coffee. I know half of you are dozing off, and because I started late, I'm not going to give you a break until 5 minutes before.
It's easy.
You okay? Sorry about that. Are we okay? You want to break badly? You want to?
Yeah, I need to go to the bathroom.
Anyone?
Yes.
Yeah.
Yeah, okay. 5 minutes.
It's perfect.
You're gonna post all this for I know I asked that again and again.
I have posted all my lectures since 1998.
I have to teach myself SQL before I have to teach myself SQL in 48 hours. Okay, Lydia Lee.
I'm the guy who takes you in the morning.
About?
For the reference for the workshop 2. So I
Oh,
already
extension for workshop
yeah,
2?
can I extend that for today so I can submit?
No, it's not a today. Read the. Give me 2 seconds. Give me 2 seconds. No, wait, give me 2 seconds. Give me 2 seconds. Let me first pause. I don't want our conversation to be recorded.
I just look at
I think I am in a meeting already. There you go.
It becomes about the speed at which you can fold meetings.
Okay, so what you just saw was what you just saw over here is the syntax of overloading a binary operator with side effect. Okay, now let's say, so, and I'm gonna, so in here I'm gonna write a CD binary operator with side effect. Okay? Now, question is, what if I want to do this? What if I want to do this? So from what I wrote, immediately you can guess that what you need to implement is this. Take a look. This is how you do operator overloading. Immediately you say, so this should be S is set to S1 dot operator plus, and then you have S2 passed to it. That's the function name for that operator. This is how you overload operators. So you look at the operator, immediately you put a dot, operator, put parentheses. This is what you need to overload. Easy. Okay? So it's a binary thing and it's not supposed to have side effects. So, which means this plus is not supposed to change S1. This plus is not supposed to change S2. Neither of those, correct? So I'm going to come over here and do exactly that. And it's returning, and it goes back to the S. So it must return the string reference. Correct? And it's operator plus, correct? and then in here, it will receive a constant string reference other. That's the right one, correct? Right? Are we okay down to this point? Now, the thing is that it is not supposed to change the owner. So let's add this one, and because it's not changing the owner, what it's returning is supposed to be a constant too. So essentially I'm saying this operator oh, sorry, I put it in the wrong place. I wanted to put it in a header file. So this is what we want. I want this operator plus to receive another one, right? I'm going to remove that const from there. I'll tell you why later. Okay? So let's put it like this. So it's supposed to return another string. I'm putting reference over there. We'll see if we're going to change it or not. And it's going to be an operator plus that receives the other one, the right one. It's not supposed to change, and it's not supposed to change the owner too. That's a binary operator with no side effect. And if I want to create this, this is what I'm going to do. So I am supposed to concatenate the value of the other one to mine, right? And then return something that is sum of the two, but the two are not supposed to change, correct? Yeah. So I need a temporary thing. I need to build it in that. So how do I build it? I simply say, okay, so first of all, I'm going to say, I'm going to create a string, return what I want to return, or I don't know, string result. Let's put it this way, okay? Now, I'm going to say result is set to me, right? Mm-hmm. So set that result, make it exactly like me. Now, result is something temporary. I can change it, right? Now I will say result plus equal other. Nothing is changed over here, no problem. Now I'm going to say return result. But result is a local variable. I cannot return its reference out, because if I say return the name of result out, when the operator is over, result is dead. I cannot return the name of a dead thing. That's why I can't put reference over there. So now this says I'm going to get, let's actually walk through it and see how it's going to work out. As soon as you do this, you will see that you're not going to get any error message over there anymore. So now when I run this program, it comes in here. Now, plus belongs to S1. So it will go to S1. And as you see, other has DEF, that is the right one. And this has ABC. The one that I'm in has ABC. Now I'm going to say set me to that one. So now result will have ABC. Then I'm going to say result plus equal other. So result becomes ABCDEF. Now I'm going to say return the whole object out. It returns the whole thing back up to S, and S is now, oh, I did it twice. I have to comment the other one. Stop, run again to cursor. Okay, so yeah, so now it comes to display, and then when it comes to display, this is going to display both of them. and that's going to be A, B, C, D, E, F. Okay? This is a binary. This is a binary operator overload that has no side effect. And it's standard with all. So exactly what you do, this is what. Again, we can do things, we can make them do crazy stuff, but when you are doing plus, please do plus, okay? Make sure that it means that, okay?
What's const after the function again?
It means it cannot change the owner. This, if I write over here, m data 0 is 0, it's going to give me an error. Say, what are you doing? You cannot, this is an expression must be a modifiable value. I cannot change the owner. That's all. It stops changing the owner.
What is the other?
It's just a name. It means the other one.
The string name.
Right operand. Better?
It's just basically a part of the function.
I just try to put a meaningful name.
I have to ask you more questions.
It's a random.
about this particular thing.
You have to, for you, you're going to walk through it several times. This is what you're going to do.
Okay.
Walk through it several times, everyone,
Yeah.
and see how it's done. So it's 55. I have more time. So next thing we need to learn how to add, how to do unary stuff, like your unary operators. For example, what if I want to add a space after? So when I have something, I want to add a space after. I want to be so this one I'm going to say binary, what do I say? CTE, binary overload, no side effect. Okay, so that's that one. Now let's create another scenario. So in here, I want to create something like this. I want to say string full name, string name, and capital S. And I'm going to say string last name. Okay? And let's have this one as Fred, and this one as Soleil. And then I'm going to say full name is equal to name. Okay? Now I'm going to say full name plus plus to add one space after. I just came up with it. Okay? Now I'm going to say full name plus equal last name. Why am I making these things uppercase? I don't know. Last name. Now, hopefully, when I say full name dot display, it actually shows me a space between the two. So I want to overload this. Okay?
Sorry.
I'm too. I am sorry too. I'll tell you why. First of all,
You didn't resume the recording.
no, it is recording. No, I'm sorry too, because that's not a good example. It's better, I want to do it like this. I'm going to do this. So I'm going to say, plus plus last name. I'm adding one space before that. then I do this. Okay? Because a normal unary operator is prefix. A postfix unary operator is an exception. But because of that, its signature is awkward. If I showed you that first, you're going to go, what the hell? Okay, so this is what I'm going to do. So unary operators are easy. So this essentially means, this essentially is this. Because it doesn't have, it only affects the thing. It doesn't have any other thing. So if you overload this, you overload that. Okay? And how do we overload it? So I'm going to simply say, I'm going to say this. I'm going to say, what do I do? What do I do? What do I do? What do I do? So let me overload it. I'm going to come over here and I'm going to say, I'm going to overload that. So first of all, I'm going to return obviously I'm going to say string reference. I'm going to return a reference because I'm going to return the whole thing afterwards. So you can put it in something else. Then I'm going to say operator plus plus, and that's it. So that's a unary operator. And I'm going to implement it. In here, I'm going to say, so I want to add a space. So I'm going to say,
It's supposed to be plus plus operator.
pardon me?
It's supposed to be plus plus operator.
It is a plus plus operator.
Plus
So,
operator plus space.
pardon me?
It's the same thing.
It is a plus plus operator. So now I want to
No, it's
do
all
an
plus
easy.
plus
I want to do an easy thing. How do I implement this for you? So it's how do I add a space at the beginning? Yes.
How about the original string is a space, then you add the name inside?
One more time.
Original string is named the space. Original.
Yes, I want to add a space at the beginning.
No. Original name string, maybe the string rest is originally a space already. Then you add another last name.
Oh yeah. I can do that. I wanted to. That's.
Okay.
That's. Let's do it. That's a crappy way, but let's do it that way. Sure.
No.
No. I wanted to do a shift to the right, and so I'll do that way. Okay, that's fine. So I'm going to say over here string space. This is awful. Space. So space, and I'm going to say equal. I'm going to do this. Then I'm going to say space plus equal this. So I'm going to add. So that one has a space. Then I'm going to say this is equal to space. Okay, and I'm going to say return this. So I added so I created a string with only a space. Then I added whatever I have to that one, so it becomes space and that. Then I'm going to set myself to whatever that one overwrites it. Then I return me. So now, if I run this program, awful way, but it works. So now in here, when it comes to all these good stuff, when it reaches to here, it goes to F11, space adds only a space, then it says this and that one, so this becomes Soleil with a space at the beginning, then it overrides me with whatever I had over there, and it returns that one, and the result will be essentially a space between the two. So it worked.
So how,
This is the easier way to think.
Yeah, yeah, I know. That's an easy way out, but very inefficient. Let's put it that way. Okay, very inefficient, but it works. So the next thing I want to do that I'm not going to do today. So the next time we are coming in, so this is prefix operator overload, and you can do this actually. You can say. We could have done this. Instead of that, we could have said full name plus equal. Right? because it's returning this, right? So essentially, it adds that one and then does this one, right? But again, remember that when we said plus plus, when you have plus plus integer, plus plus happens before this statement. If plus plus comes after, it happens after the statement. When you overload it, that doesn't happen. It's just a function. You have to jump through hoops to simulate that. It's just an overload. Remember, when you overload the operator, all the behaviors of the operator down the drain. Okay? So please go through all these, okay? And the next day you are coming back during your lab. Do we have a quiz this
Yes.
time?
Yes. We didn't do the last one.
So we have a quiz when you are coming in, right? Do we?
Yeah.
You didn't announce anything?
So, ta-da! Let's announce it. So, so because this is week 5, right?
Four.
No, it's 5.
It's fine.
5.
Hell yeah.
So you're going to have a quiz this week, you're going to have a quiz next week, and you're going to have a midterm after that. So 3 weeks back to back, you're going to have, okay, be aware of it. But quiz, I'll give you the question. So you're going to have the question before the quiz. Yes, sir.
The midterm is like similar to the labs, like the midterm.
What do you mean similar to the labs?
I mean like the real question is
Do we have a sample example before?
Oh, yeah, all of them. All the, like the quizzes, you mean?
No, like the midterm.
Yeah, midterm, is like all the, anything that I do, I'll tell you what the ballpark of the question is. The only thing that you don't know are the concept questions. The concept questions are from all over the thing. So you read those notes, concept questions come from those. Huh?
Do we have to do the attendance?
Oh, yeah,
Yeah.
attendance.
Attendance on the thing.
It's quick, no?
Oh, not all of you have a notebook. Everybody has a computer now.
You can do it off your phone as well.
I'll turn off.
You know what? I'll do this. I'm going to tell you what the code is for it. Okay.
All my electronic part.
Yeah, but how early you can get to your electronics? Like an hour, 2 hours?
Maybe I take it
No, forget it. Okay, forget it. No attendance today. No attendance. I told you. Sometimes I do it, sometimes I don't. Today is one of those days.
No attendance?
But I bet it's cool. You just put it.